Now, don't worry because this isn't something we have to memorize, but we do need to get familiar with it and learn the basics. And of course, I'm talking about hex, binary, decimal, and all that great stuff. And in this nugget, we're actually just going to do a quick review over how to, or basic identification and the simple math that actually goes behind it. So I'm going to make this as painless as possible because this is not something that we have to memorize. We just have to be aware of what this is, how it's done, and if we need to use it later on, let's say spur of the moment, and we have just an idea of what it is that we need to do and how we do it. Now, of course, I do want to point out again, the last page has a master conversion chart in our supplemental files of almost every possibility that we will run into when we do network analysis or network monitoring. So in, let's say, just a weird one, we have a decimal of 255, and the binary for it is all ones, and the hexadecimal for it is FF. So don't be afraid to use this chart and any other source out there to be able to do this, because it's not like the real world is going to be a testing environment. You can have stuff like this on you if you need it. Now, that being said, what we're taking a look at here is a graph that's going to fill in as we go through the different portions of it. And on the first line is how we actually count binary. So we see that we start from the left and work our way all the way over to the right, starting at 128 and going back down to 1. Now, for those that were into networking before this may look a little bit familiar because this is actually how we do subnetting to a certain degree. So let's go ahead and reveal our next line, which is 0000101. Now, that's our traditional binary type format where we have nothing but zeros and ones. And revealing it to the side, we have that this is a decimal equaling 9. Now, where do we get that from? Well, if we notice that the first one that we run across going from left to right is under the 8 column, and the next one is under the 1 column, we're simply just going to add those two together and get 9. And that gives us our decimal formatting. Well, on the next line, let's go ahead and reveal it. We have 0000111. Now, I'll give you just a second to figure out what this equals up because, again, we're just adding the 4, the 2, and the 1 column. And if you guessed 7 or got 7, you are correct. This is a decimal value of 7, so we have converted from binary to decimal. And behind door number 3 is our last one, where we're going to go 000010011. And by their powers combined, it is equal to 19 because we're adding 16, 2, and 1. For an added little bonus to this, I'm going to add another column in here. And you'll notice on the top right, I just revealed it. It's hex, short for hexadecimal. Now, this is going to get a little wonky really quick because in our first column, we said that we had a decimal value of 9. Well, that equals 9. You may be thinking that's not too bad. And in the next column, or the one right below it, we have a decimal of 7, and that equals 7. Well, in our third example, and I'm using this one because it's pretty easy to figure out, we have a decimal value of 19, but our hex value is, I'll give you 1 second, 13. Now you may be thinking, what in the world is going on here? And that's what I first thought when I ran across this too. But now I'm revealing right below it, and you can see that 19 divided by 16 equals 1 with a remainder of 3. And if you can see, that does calculate in there. Now, for those playing at home, if you did 18, a decimal value of 18, which would be binary 000010010, your decimal value would be 18, and your hexadecimal for that would be 12. Not just because it's one lower than 19, I get it, but it's because 18 divided by 16 equals 1 with a remainder of 2. Now, there are many different calculations that we could do with this because of the fact that we have to divide by 16, and that's hexadecimal. But we're making this easier on ourselves and just referring to the chart that we have to be able to do our conversions. Now, if you're like me and you get, some of this kind of overwhelms you sometimes, that's okay too, because what we're doing now is going to take a look at an actual website that we could use to kind of help us. And I go to this site all the time to be able to do bigger conversions on if it's outside of what I can do in my own head. I go here because I don't want to strain too hard over it, and I just go do a quick decimal to hexadecimal conversion. And this also does binary. And if you scroll down after we do one, it'll actually show you the steps of how the math actually got involved in it. I will put this link below. So what we're doing now is we're going to do a simple decimal, which would be, let's say, 126, and we're going to make sure it's set to hexadecimal and do a convert. And we see it converted to 7 echo, which is 007 echo. The binary for that is 1111110, 7 digits. And if we scroll down, we can see right here, this is where the math is actually done to give us where we got 7 echo and how it lined up and everything like that. So I know that there's a lot of math that goes into the actual hexadecimal conversion of this, but thankfully for the purposes of this course, and if there was an exam associated with this, we don't have to do the math in our heads while we're on the test. What this is just giving us familiarity and figuring out what's actually going on behind the scenes. Because when we break those packets down like we've seen before, there is hexadecimal, and we may need to convert it for whatever reason from hex to decimal or binary. Now, like I said, that was just a quick familiarization because we didn't want to go too deep into the math. It's not like we're trying to do calculus here or anything like that. But in the next skill, we're going to be diving more deeply into Wireshark. So that one we will get wading all the way up to the waist in the swamp on that one. But that's okay, because the more we know about Wireshark, the more we're able to analyze the traffic that's coming across the wire and can make a better determination of that traffic for those folks up in the C-suite with the security policy and whatnot. So I hope this has been informative for you, and I'd like to thank you for viewing.